Hi, welcome back. I'd like to talk for a little while about measurement scales. You may not think of them, obviously you just want to measure things. So the question, why do you need to know about scales? Well, the reason why you need to know about scales is if you choose the wrong measurement scale, your ability to do some form of analysis or arithmetic computation with it gets compromised. So you need to know, what is it you're trying to achieve in the end, and therefore what kind of information do you want to get at the beginning, and what kind of data do you need to collect. So it matters. And one of the comments, the question that people ask is, well, isn't everything all mapped to numbers anyway? You can. That doesn't mean you can do arithmetic with it. Isn't everything all mapped to numbers anyway? You can. Different scales. There is the nominal scale. Different scales. There is the nominal scale, and they are categories onto which. And we map these onto some scale, some appropriate scale. And we map these onto some scale, some appropriate scale. Of them is the categorical scale. So attributes of something can be mapped to a categorical scale. There is no ordering, there's no sequence, there's no particular value associated with it. An example of a categorical scale is color. The fact that something is blue doesn't say anything about its relation to something that's red. It's simply an attribute of something. A real example of that is if we're dealing with an analysis of the university and we want to know something about the graduates, the undergraduate degrees in various faculties. About all we can do is count the number of them. We can't say anything about the relationships of the degrees from one to the other. There isn't any implied relationship. The next scale, usually in sequence, is the ordinal scale, where things have some sort of a rank order. You can put them in a sequence. You probably can't say much about the sequence other than that these are in a sequence. We know that something is further up the scale than something else, but we don't know by how much, and we don't know what the relationship is between them all. The examples of ranking scales, we'll deal with that, I guess, in a little bit later. The interval scale is next, and this is where there are regular intervals in the scale. Now with this, you can do some arithmetic, not much, but you can do some arithmetic. You can do addition and subtraction. The last scale, probably the most useful one, is the ratio scale, where there is a zero and there are regular intervals. Now, this means you can do multiplication and division as well as addition and subtraction. So they're the four scales, and for measurement purposes, they're the only four scales. Having said that, that's not entirely true. You can get a composite of only four scales. Having said that, that's not entirely. Now let's have a look at nominal scales. These are. Now let's have a look at nominal scales. These are in how many people graduated with different degrees. There isn't any in how many people graduated with different degrees. There isn't any. All we can say is we have so many graduates with these degrees. All we can say is we have so many graduates with these degrees. And possibly we could say something about, for example, the relative success of different faculties for getting students through. So what are the dropout rates in the various undergraduate degrees? We could do something about that. But now we're comparing dropout rates, not degrees themselves. There isn't any ordering that you can imply. You can't, for example, say that an engineering degree is bigger than an IT degree, or an IT degree is more complex than a science degree. There is no relationship like that unless you're going to measure the complexity or the difficulty or something. And now we're not dealing with degrees themselves. There are some statistical tests you can do, and that the only test you can really do with categorical variables is the chi-squared test, and that is some sort of measure of the frequency of things. Some sort of measure of the frequency of things in the various scales exist in a number of areas. One example from university life is the ordinal scale of what are they called? Your subject grades, where you go from a fail through a pass, credit, distinction, high distinction. That is an ordinal scale. We also have things like restaurant ratings. We have unrated restaurant, a one star, or 1 hat, 2 hat, 3 hat restaurant. By the time you get 3 hats, you're doing pretty good. Another one would be consumer ratings. 0 to 5 star is quite a frequent rating scale. When it comes to car safety, I think it goes up to 6. For environmental ratings of buildings, this building that UTS is in is I forget whether it's rated as a 6-star environmental building or not, but certainly the environmental ratings go up to 6 stars, or a grade of 6. Competitor rankings in tennis and golf, the various professional athletes are ranked from the number 1 being at the top through to how they are. An ordinal scale in many ways admits the limitations that we have on our ability to measure it. We can only measure some things fairly approximately. A tennis player ranked 50 is not twice as good as a tennis player ranked 100, for example. We just can't say that. And similarly, if you're dealing with restaurants, 3-hat restaurant, it could be just marginally better than a 2-hat restaurant, or it could be a lot better. We don't know. If we combine a whole lot of information, we could come up with a much more accurate measure. But we're dealing with things that really cannot be classified or cannot be combined so easily in that way. So an ordinal measure is we use that when in many ways we can't be more accurate than that, and probably we don't need to be more accurate than that. Ordinal scales don't have even intervals, which is what I've been saying. The intervals really could be very lumpy, and we have an example there. If we went to all the trouble of measuring something quite accurately, and we could have we could actually determine what they are. Then, if previously we had something that ranked A, B, C, D, E, and just in that ratio, we could, for example, find that we measured it was 2, 4, 36, 37, and 78. So you can see that it's not even intervals. It's just, well, that's the order of them. And within the same sample, we could have something else also ranked A, B, C, D, E, and they could have values of 0, 1, 2, 3, 4. Now, we can't really say a lot about the relationship between the two A's or the two E's, other than their relationship to each other. So ordinal variables do tell us about the order of things, but beyond that, we can have some difficulty. In ordinal scales, arithmetic is possible, but dangerous. I have a colleague who gets quite upset about unjustified arithmetic on ordinal scales. Now, strictly, you're not able to perform any arithmetic on ordinal scales. You can't add or subtract and get any meaningful answer. However, there are a number of ordinal scales where there is good reason to say, well, they're almost an interval scale. That is, they are well established, the scales are reasonably close together, or they're reasonably evenly spaced or something. And we have good reason to argue that they're close to an ordinal scale. And in those circumstances, the benefit from treating them as interval scales outweighs the strict restriction, or the breach of the strict conditions of not being able to do arithmetic. I've been in circumstances where that argument has prevailed, and where it's been argued against. If you want to be quite categorically correct, you can't perform arithmetic on an ordinal scale. Now, interval scale, you're probably very familiar with these. Interval scales occur quite a lot. Things are even, but the scale doesn't start at 0. Now, examples are temperature, the Celsius scale and the Fahrenheit scale. 0 is not no heat. It's been pointed out that even 0 degrees is not actually no heat. You can't actually achieve it. So, talking about something at 50 degrees Celsius being half as hot as something at 100 degrees Celsius doesn't make any sense. You're not talking about half as much heat. You're only talking about its relationship on that scale. So that restricts what you can do. With an interval scale, you can add and subtract, but you can't multiply or divide. You can't calculate ratios of them, for example. Now, with a ratio scale, you can multiply and divide. It is a ratio. You can do all mathematics as possible. The examples of that are height and weight. 0 corresponds to none of whatever the attribute is. So 0 length means you've got no length at all, and 0 weight means there is no weight. So that's easy. Now, here is probably the most useful chart you're likely to find, and that is what statistical operations can you perform on these different measures. If you're dealing with a ordinal or nominal measure, the only thing you can do is to measure the mode. That is the most frequently occurring thing, or the category with the most frequent occurrence. You can do non-parametric statistical test. An example there is chi-squared. That's probably about all you can do if you're trying to infer anything from it. So, with ordinal scales, you get a mode, median, and range, but you don't get a mean. Talking about a mean of an ordinal variable just doesn't make sense. There isn't one. You can do some non-parametric tests. There are the Mann-Whitney test, the Kruskal-Wallis test, the Friedman-Hanover, and the Spearman correlation. Now, these are all statistical tests that people have developed to take account of the inaccuracy that comes with ordinal measures. They're quite useful. With interval and ratio, you can do the mode, median, range, variance, and statistical deviation. And the tests you can apply are very much the same. You can do a t-test, an Hanover test, a Pearson correlation. So you can do those with the intervals and ratio scales. So that's about scales. Most of the problems I've seen have occurred when people are dealing with an ordinal or a categorical scale and then trying to do arithmetic on it. Or they've gathered data that is ordinal or categorical and suddenly find they need to determine some sort of relationship between that and something else. And they can't do it because the measurement scale won't support it. So this is why it's important. You need to know what you want to do with the information before you gather the data in order to ensure that you're gathering the data correctly and gathering the correct data. That's why it matters.